Next example, we changed the function to the square root of x plus 1. We changed the interval from 0 to 2, and we changed the number of partitions to 8. So I like to start by figuring out what our delta x value is going to be. We're going from 0 to 2, but we're dividing that into 8 pieces. So the width of this interval is 2. We're going to divide that into 8, so 2 divided by 8 is 1/4. So we already see that here, but we've got an interval of 1/4, another 1/4, and all of these are a width of 1/4. So that's going to be the width of each of our rectangles. So I can just go ahead and put this 1/4 right here. And since it's not going to change, we'll just draw an arrow there. For all of these problems on this worksheet, the width is going to stay the same. Normally, when we do a Riemann sum, the widths are going to stay constant. Sometimes we'll see some problems every once in a while where the width is not constant, but those will be the exception rather than the rule. And normally they'll be given in a table form instead of as a function. At any rate, once we have our widths, we can try to figure out our heights. This time we're doing a right rectangular sum. So you might be able to figure out what's going on there. We've got the first subinterval goes from 0 to 1/4. And we've got a left side of the rectangle, and we've got a right side of the rectangle, but it's the right side that determines the height of the rectangle. So when the right side hits the curve, the square root of x plus 1, when the right side hits that curve, we know that that's going to be the height. Now, it's worth noting that the right rectangular sum method that we did on this problem, that we're doing on this problem, is producing an overestimate, right? Each one of these rectangles, like this next rectangle, is also, we're going to use this right side to go all the way up to the curve, and that, as we go to the left, we see that the rest of the rectangle is too big over here. There's a little triangular shaped wedge, almost triangle wedge, that's too big. So this estimate is going to be too big, just like this one, where the rectangles were above the curve. But this was a left problem, and this is a right problem, and we're getting an overestimate each time. So I encourage you to think about what the difference between these two functions is, where the left on one of them gives you the overestimate, and the right gives you the overestimate on the other. But going back to this problem, we know that the first value that we're interested in here, the first x value, is the right endpoint of the first subinterval. That's going to be our starting point of 1/4 for x. That x value of 1/4 determines the height of our first rectangle. And then we're going to add our width each time. So we're going to add and get 2/4 and 3/4 and 4/4, 5/4, 6/4, 7/4, 8/4. And when you think about it in unreduced forms, that makes it easier to determine that the ith x value is just I over 4. No matter what I is, if we just divide that by 4, we get our x value for this particular problem. So once we have the x value, we can use that to find the height of the rectangle. So that's going to be the square root of 1/4 plus 1. And I'll just quickly fill out all of these. And we're going to have to take each one of these and multiply it by 1/4. And I think that it might not be worth our time for me to rewrite each one of these for the area. So I'll just do the first one. We've got 1/2 plus 1 is 3/2. We're going to multiply that by 1/4. Which is going to give us 3/8. That's the area of the first rectangle. Most of them aren't going to work out nice and neat because the square roots aren't going to be rational answers. So I'll just say we're going to multiply our height times our width to get our area, but really the most important one is down here. We're going to take our height of the square root of I over 4 plus 1. That's our height. Our width is 1/4, and that is exactly what we're going to put in the summation. So the summation is going to start with I equals 1 like it always does. It's going to go to 8 because we have 8 partitions, and we're going to add up the area of all of these rectangles. The generic ith rectangle is going to have a height of the square root of I over 4 plus 1. And then each one of these rectangles has a constant width of 1/4. And that's all we need. And then when we type that into the calculator, we take the sum from I equals 1 to 8 of the square root of I divided by 4 plus 1, and we multiply that by 1/4. We find that we get an answer of about 4.038. And just as a reminder, this is an approximation of the area bounded by the curve, square root of x plus 1, and the x-axis between the x values of 0 and 2. And graphically speaking, that's the shape that has this vertical line right here, this curved top, this vertical line right here, and the x-axis is the bottom. It's the area right there. That does not equal 4.038. It is approximately equal to 4.038. In fact, we know that it's too big, and the actual answer is going to be a little bit less than 4.038 because each one of those rectangles that we added up had a bit of overage. It stuck out over the top of the curve.